Today we're going to take our knowledge of adding and subtracting and we're going to apply it to something new. This is something you haven't necessarily done before. We're going to work with polynomials. So what is a polynomial, you ask? A polynomial are terms connected by addition or subtraction that have no division of variables or negative exponents. So for example, 3x to the fifth plus 7y squared plus 12xy to the fourth z is a polynomial. And when we add and subtract polynomials, we need to combine like terms. And what we mean by like terms are terms with the same variable and the same exponent. So for example, 6a and negative 8a are both like terms because they both have an a to the first power. Likewise, 10VW cubed and VW cubed are like terms because they both have a v to the first power and a w to the third power. Now, an example of non-like terms are 5gh and 5g squared h. The reason why these are not like terms is because while they both have a g and an h in them, the second one has a g squared h, while the other one only has a g to the first power. And I like to put some concrete examples to correlate with the variables to get you an idea of whether you can combine them or not. And if you can combine them, it would be things that if you put them into the same bowl or into the same pen or together in some way, you wouldn't be able to tell the difference between them. The next piece I wanted to talk about before we get actually combining like terms is standard form. Standard form is when a polynomial is written with the highest degree first in descending or lowering order. So for example, 5x to the fourth plus 10x squared minus x is in standard form because first we take x to the fourth power, which is highest, and then x to the second, and then x to the first. So it lowers in order by the power of the degree of the term. The second one, 8x to the fifth, y squared plus 2x cubed, y cubed plus 3x squared. We always want to go alphabetical order. And so the x is what is more important to us about highest degree. So we have x to the fifth, then x to the third, then x to the second. So let's first start with adding polynomials. Looking at this first example of the polynomial 15x minus x cubed plus 3 plus the quantity 5x cubed plus 10x minus 5. I like to use different shapes and symbols to define. So first thing I want to look at is highest degree. And when I combine them, I look at it with the symbol in front of it. I realize these are adding and subtracting signs, but adding and subtracting mean the same thing as positive and negative. So if you think of them in terms of positive and negative, then that means you can put pluses in minuses based on whether they're positive or negative in front. So first I look at negative x to the third and 5x to the third. And the reason why I'm looking at these first is because the power is highest. So a negative 1 plus a 5 is 4x to the third. And then I have 15x. Notice I'm making boxes now, so it's different. You can also use color if you wish. A lot of people last year chose to use color with the highlighters. 15 plus 10 is 25. And they're both positive, which is why I added them. And then I have a plus 3 and a minus 5. Well, 3 minus 5 is negative 2. And this would be my final answer in standard form. Looking at the next problem, we have 3a squared plus a plus 5 plus the quantity 2a minus 5. As you can see, this is the only a squared term, which means I bring it straight down because there's nothing I can combine it with, but it doesn't disappear. Then I have a plus a and a plus 2a, which remember, if there's no number in front, it's a 1. So 1a plus 2a is 3a. And then I have a plus 5 and a minus 5. Well, positive 5 minus 5 is 0, which means that we wouldn't put anything. You could put a plus 0 and it wouldn't be wrong, but instead let's just make it simple and not do that. Then our last one, this one's a long one. We've got f to the 4th g cubed minus 4f squared g squared plus 11f plus the quantity negative f squared g squared plus 8f to the 4th g to the 3rd minus 3f. When I look at this problem, f to the 4th is the highest. I have an f to the 4th g cubed and an 8f to the 4th g cubed. So this one, remember, has a 1 in front of it, so I end up with 1 plus 8, which is 9f to the 4th g cubed. And then I have a negative 4f squared g squared plus a negative f squared g squared. Negative plus a negative is more negative. This one also has a 1 in the front, so it's minus 5f squared g squared. And then finally, I've got a positive 11f minus 3f. 11 minus 3 is positive 8, so we got 8f.